Hey guys, Joe Pye here at Advanced Innovations. Welcome back to my shop. I think that very possibly all the inside parting lines are filed off to my satisfaction. This was then put back in my blast cabinet and blasted with a very aggressive black sand media. And I believe we are ready to do some turning. I'm going to pinch this against a faceplate with a couple of strategically placed clamps. Try to true it up, get it to run visually appealing. And then we'll see what diameters need to be touched and dressed and blended. Good way to put it. Blended. Something like this. Actually, any casting, to make it look good, you got to fake something. Let's go over to the lathe. Show you what I'm doing. For all the OD and facing and boring work on this little flywheel, I'm going to use an aluminum plate and put the part on the plate. Part will be on standoffs on 3 points, not 4. If you don't know what you have, if you don't know your part is exactly perfectly flat, don't use 4, because all you're going to do is bend it straight when you clamp it, and when you unclamp it, it's going to go boom. 3 points, okay? 3 shims. On the first side, if you want to use 4 on the second side or make full contact on the second side, go for it. First side, 3. Going to drill a few holes in this plate and secure it with clamps across the spokes every 120 degrees. 3 spacers, 3 clamps. Now, one of the dangers, not really dangers, but one of the considerations you have to have when you hold a piece of round stock in a vise like this is if you're going to drill over here, well, you're between the parallels and any pressure could cock the part. So make sure your setup has enough integrity that that doesn't happen. Use wide parallels or know your bolt pattern. Space your parallels midway in the part so you resist that teeter-totter motion, and all should end well. I'm going to pop 3 1032 holes in here. That's about, what is that, 5 millimeters-ish. I'll be right back. I am going to move over to the lathe, put this in the lathe, take a nice dust cut off of this so I know that it's true to the machine. Then I will struggle getting the shims and the clamps on with it in a vertical format, because gravity is not your friend in a situation like that. So let's move over to the lathe and finish this thing off. The operation that you just saw me do to thread these holes is called power tapping. With a coordinated forward and reverse motion of the spindle, you run the tap down in there and you run it back out. Now, occasionally you get lucky and you get a perfect thread. Let's try something. Nope, that one's tight. I'm going to tell you why here in a second, so just bear with. And that one floats right in. No rhyme or reason, right? Same tap, same speed, same lubrication, same everything. Well, maybe not the same everything. Usually a situation like this where you have a tight screw after a power tap operation, that just means that on the way out with the tap took the top lead thread and distorted it just a hair because the timing of your quill was not with the timing of the pitch. Easy way to take care of that. Run it until it binds. Don't power it, and just run it until it binds. Put your Allen key on there and rotate the Allen key, pushing to the outside like a tornado, like a cone shape. Just like that. Do that a couple times. Realign that top pitch. I guarantee if you do that, you're going to be surprised at the results. You're going to think you got a bad thread. You're going to want to retap it. Don't do it. You don't need to. And this one here is tight as well. I'll run in just a hair. Massage it a little bit. There you go. Keep that trick in mind. That is a fantastic trick. And after a while, your feel for the pitch of the tap versus the movement of the arm is going to be second nature. Best way to do that is actually not look at it on the way out because you anticipate it releasing and you pull. Look away. You can feel it moving. Just move completely clear of the part. Now we can go over to the lathe. Let's do it. The nest is successfully back in the chuck, and in order to achieve a flat surface, I'm going to face it off. Now, if I'm real lucky, I'm going to get a good finish, but when you face across interruptions like this, you're going to see little comet marks behind the interruption, and that's just because of the change of the load on the tool. Okay, the one time I expected it and didn't get it. There you go. Nice clean face. If the countersink on the screw holes was not sufficiently large, you may have rolled your top thread over. Be careful of that. And give me a couple of seconds here off camera to fuss around with these clamps. I know this is going to be a joke, but I'll come back for the final alignment. Hang in there. The part is now secure against the faceplate or against the small backup plate. Shims in place, in line with the screws. So we do have 3 points of contact here. I've tried to get it to run concentric with the features that I will not machine, and that's the ID of the rim, this edge right there, and the actual area where I filed. So with it spinning, I was looking for consistency there. If the OD of the part is not true to the inner part of the rim, it's going to appear to run out as the wall gets thinner and thicker. Let's power up and take a look. I think the most visible section of runout, you can look at the top up here and you can see it's just oscillating just a little bit. This needs to be bumped a little bit more before I'm happy establishing the OD, and that'll make it even land on the front of the part. Let's bump it around for a second and come right back. Now I'm going to unloosen the clamps, trying not to lose my shims, and just bump it with a plastic hammer. completely by eye. Let's see what happens. Better yet, let's turn this. ID is running true. OD is eccentric to the ID, but I think on the first cleanup cut on the OD, you're going to see that fall right in. I'm very pleased with that. This is a go right here. Get tooled up, get ready. I know I'm going to be facing a little bit of material off the front and rear of this casting, so I choose not to hit the shims. If the force of the cutter hitting the shim tears the shim out, this could not end very well. So I like the concentricity of the ID and the OD. I think that fell in real nice. Going to get out some measuring tools and bring the OD in. I'm going to get to work on the face and the bore. I will probably drill that out. And then tap the arbor, put a screw in here, hold this up against the shims with a screw, remove the clamps, cut the hub. The hub is still running out, and that is just talking out loud. That in fact may not be the way I do it. I might finish the bore, which would probably be the best way to go. Finish the bore, then put the screw in, then hold it down, then turn it, and then stand on one foot and rub your belly and pat your head at the same time. All right, let's finish the OD. Be right back. If I cut this casting to the dimensions on the print, I am going to lose a great deal of this inside lip right there. And I like the way that looks. I like the fact that it's got a protrusion. I don't want it to be flush with the inner contour, so the inner contour comes out, just rolls right out. I like the lip on it. So I am going to cheat the dimensions a little bit. Not by much, maybe 0.5 millimeter, 20 thousandths of an inch on per side, that is. Per side. So instead of being a 1/2 inch, 0.500 thick, it'll be about 540. I guess that's what, 12.5, 12.7, 13.7 thick, 13.7 millimeters thick. I'm going to take another 20 off of that and call it a good. Then I'll go to the middle. Let's do it. And for anyone curious what I'm doing here, I got a TPG insert in here. That's a triangular positive edge insert. It's a 15 thousandths radius on the nose of this insert, and this machine is running at 320 RPM. TPG insert, triangular insert. 15 thousandths radius, 320. No need to push it. Oh, that's close. Yes, it is. It'll look a whole lot closer when it fires up. Actually, it looks better. Slight deburr on the inside edge. And a nice deburr on the outside. Let's drill and bore the inside. Be very careful when center drilling an irregular surface. The surface may influence the center drill. And I got it sticking out like that so you can see what's going on for anybody that's going to comment. I'm going to put a light drag on the quill, and I'm going to bump this until I'm sure that I have a true tracking, non-influential feature. How's that for a mouthful? Go to 425 on the RPM. Hit it. By bumping it, I mean I am not going to commit to a feed until I know I have a good track in the center. And I would say we're there. Keep an eye on the center drill, keep an eye on the feature, make sure everything is staying true. The regular surfaces can wreak havoc on initial operation, so start tight and right. Now, although the cone in the center is running true to the part, if this surface is irregular and running out, you have a high side and a low side on that cone, although it's concentric. So right now I'm going to take a boring bar and I'm going to make a dust pass on this to bring in that particular center drill feature true to the world. And that's the camera jumping around. There we go. Concentricity fixed. While you wait. Watch for the interrupted cut. Yep, you can hear it and see it. Now we're good. Quarter-inch drill, 281 boring operation coming up. OD done, face done, bore done. Let's flip on the back side, cut it to thickness, and call this one complete on the lathe. Got to put a set screw, a grub screw in there to lock this onto the shaft, and we'll make sure that we put a mating feature on the shaft so that we can get this on and off as necessary. Well, the part has been reversed and locked down and indicated to the faceplate that it was connected to initially. And as with any two-sided casting, you can only see one side at a time most of the time. And watch the inside of the rim. Naturally, this flash on the outside will come off. How's that for getting close to the shims? Boom, carbide fingers. You can see the eccentricity of the hub to the bore on this side. And we're going to have to touch up a couple things and make this look good. That is not to my satisfaction. That's a little bit eccentric. Not nearly like the other side, but you got to pick a feature and stick with it, right? That's what makes it interesting. Let's clean it up and see what we can do. And just in case anybody's wondering, the surface that the wheel is connected to is proud. So I can bank this tool against that surface and then just simply back out and know how thick this part is without having the way to mic it. So that's first. I'm going to register against the arbor, and that'll be ground zero. Going to grind up a high-speed tool real quick with a little radius on it. I can get in here and kiss the inner edge. I may have to blast it again to blend it, but I can't do with the eccentric nature of that as it spins. See how the inside's running out? That is just not going to happen. I'll show you the tool before I make the cut. This is the tool I'll be using. Hopefully this face here on the inside will be true to the face of the rim, and I can use this little slight round here to fake that inside radius back in. There we go. I like it, but I'm going to go with a little bit more of a round, a little sharper on this corner. Sharper angle, bigger round. Be right back. You know, I think I'm going to quit while I'm ahead. I would love to machine that casting remnant out of there, right there in the corner where my fingernail is. And there's a couple more coming around right there as well. But I think it's probably pushing my luck. I'd like to blast it, see if it blends when I blast it. And I'll put it on an arbor and turn this diameter right here, clean that up. Because that is just ugly. All right. I'll get a boring bar and face that off first so I can use a screw to hold it down on the arbor. There is a specific height for this face to this face right here. So I'm going to bump the tool against the outer face, zero my digital. I'll know how high that is going to be. I would say that's an unexpected treat. It doesn't look so bad afterwards. Maybe a big chamfer on that, we'd call it a day. But nah, that would be cheating. I'm still going to turn that inner hub because there's an artifact on there from the casting op. There's one on the other side as well that's got to go. Part is currently on the same arbor it's been on the whole time, only now I'm using a center screw instead of the 3 clamps on the outside. I'm going to true up the center bore and tell you, I'll show you there's an artifact on here that's kind of ugly. There it is. How's that for ugly? That's got to go. So we're going to clean up the hub, make it run concentric, and I may dust the inside the same way I did the back side, just because I think I like the way it looked when it was machined. So let's clean this up. That actually runs fairly concentric. This was the first side, so in all fairness, you can't do both sides at the same time, right? Oh, maybe you can. Who knows? Let's clean it up. See if I can nip that off right there. Alright, close enough. Let's clean up the inside of the rim, polish this thing up, and get over to the mill. Now, after I flip this and do the same thing to the other side, I won't show it because you just saw it. But I will show the polishing. That's, I like that. I've got the part back on the arbor, and just like the other flywheels that I've done, I am not going to machine the OD of this to the shine that I'm looking for. I'm going to file it. I'm going to use a nice flat file, a file that I know is flat and that is dedicated for full contact. So I'm not going to get any digs or anything in this material. I'm going to keep flipping the file over, keep the file clean, and I'll finish up with a Blue Magic metal polish. And by the time I'm done, this should look like chrome. Let's see if that's how it works out. Well, it took a little finagling to get the circumferential scratches out of it. The material is very delicate. I had to ultimately take a piece of fine emery and go in a crosshatch pattern, and then erase the crosshatch with a very small forward and backwards pattern. And then I did the same thing with the polish. And this is what we got. I could spend more time on it, but I think for what we're looking for, that's plenty good. Let's get over to the mill, pop the hole in there, pop the screw in there, call this one done. That looks quite a bit different than when I started. I'm very pleased with that. I like it. This is a nearly identical setup to the setup that I used for the PM Research steam engine flywheel grub screw. And the idea behind this, the 1, 2, 3 block in the front clamped to the 2 tool bits keeps the tool bits parallel and allows them to be moved in harmony when I adjust the angle to the vise. This down here is just a spreader block. And for the actual setup, these come off, but don't go away. These don't go away. And the flywheel itself will come back and get clamped to this face right here. One clamp on either side with a shim to distribute the weight or distribute the load. I do not intend to put the screw in line with one of the ribs because sometimes that gets in the way of whatever mechanism you're using to drive the screw. I'm going to make sure that one of the ribs is straight across the center. That will assure me that the grub screw goes in between the 2 spokes that are vertical. I'll put a pin in here, indicate the pin, and locate the screw by eye. With a pin in the bore, sweep the pin, get the center line for the y-axis. Now, in all fairness, I did this off camera, so I wasn't futzing around with it. But find the high spot, and then find the low spot. 0. Bring it back around, and you're just going to have to trust me because I'm not going to move the camera for this. 0. Going to put a pointer in the drill chuck now, and I'm going to move into a point midway on the hub, put the screw in. This piece is done. In order to assure that the drill and the tap are not influenced by the incline of the feature right here, my first operation is going to be to put a small spot face on that with a 4-flute 125 diameter end mill. 1/8, 3 millimeters. All right, let's pop it out and take a look. Well, that's a wrap, people. This is the end of this particular part. I am very pleased with the way that came out. Let's put that on the rod here. Give that a spin, see what it looks like. Well, it's not spinning at 2,000 RPM, but I popped it on the arbor and the lathe, and I like the way it looks. Definitely more work than you would think. This is one of those parts that you're going to look right past when you look at this finished model. You're just going to think, well, it came out of the box that way. And I think that's probably the best compliment that you can give somebody is when you don't even realize how much work went into a specific part because you think, well, it's supposed to look that way. Put yourself into every piece you do. Take your time. Be proud of it. Autograph your work with excellence. That was a motto of one of the companies I did my apprenticeship at. And, you know, it's stuck. And it's so true. That's all I got. It's the end of this one. Thank you very much for tuning in wherever you are in the world. I hope you're well and happy and safe, all of the above. Me, I'm Joe Pye here at Advanced Innovations in Austin, Texas.